Chapter 8, Lesson 5 of Geometry, and we're going to talk about angles of elevation and angles of depression. Now, these angles of elevation and angles of depression are very common applications of trigonometric ratios because it's very easy to create a right triangle or to superimpose a right triangle when we're talking about looking up at something or looking down at something. Right triangles and trigonometry are applicational of these types of circumstances, so we're going to run into these problems quite a bit. So what we want to do in this lesson is get a good definition and working understanding of what is an angle of elevation and what is an angle of depression. How are they the same? How are they different? And then how can we apply those to different types of situations when we want to measure things indirectly? If we take a look at this example here, we have a person on the ground that is looking up at a person that's in this hot air balloon. Now, this line that's drawn here is the person, or not the person, it's the line of sight, what we call the line of sight. Now, the line of sight is the line that goes from your eye to the object that you're looking at, and that line is always a straight line. And it's invisible, we don't really actually have a line, but that would be the line upon which we would have to look in order to see from the ground up to this person. Now, notice that in order to look up, you have to look above horizontal. In other words, if you look straight ahead, that would be a horizontal line. In order to look up, you have to look above the horizontal line. And so your line of sight goes above the horizontal line. So if you put those two pieces together, then the imaginary horizontal line of looking straight ahead would be one side of your angle. And then the line upon which you're looking, your line of sight, would be another side of the angle. So if you're looking up, you have to elevate your eyes, so angle of elevation. Now at the same time, you have a person that's in the balloon and looking down at the person. Now they're going to be looking along the same line. To see the person down there, they're going to be looking along the same line that the person is looking up to them. Now, just like the person on the ground has to look above horizontal in order to see up, the person that wants to look down must look below horizontal. Imagine looking straight ahead. If you want to see below, you have to look down. You have to depress your eyes, so to speak, or you have to look down in order to see that. So again, if you think about the horizontal, the imaginary horizontal line being one side of the angle, your line of sight being the other, this is our angle of depression. So if you draw all these imaginary lines in, you have two horizontal lines which are parallel, because all horizontal lines are parallel to each other. Your line of sight becomes a transversal, and so this angle of depression and this angle of elevation are alternate interiors, so you can see that they are equal angles. Okay? So to summarize what we've talked about so far then, when you're talking about angles of elevation and angles of depression, they're both involving the line of sight from an individual to an object. And that line of sight is one side of an angle. Both the angle of elevation and angle of depression involve a horizontal side as a side of the angle. Now this is very important for you to remember, that an angle of elevation and an angle of depression must have a horizontal line as one side of the angle. Remember that as we move forward. Very important. And then angles of elevation and angles of depression are alternate interior angles, and therefore they are congruent. Alright, so those are some definitions. Now let's talk about some mistakes that are made when we're talking about angles of elevation and angles of depression when we're applying those, and then we'll do a few examples. The most important thing to remember, as I talked about earlier, is that one side of the angle must be horizontal for it to be considered an angle of depression or an angle of elevation. And the most common mistake that's made is when students draw a triangle to represent the situation and they're told about an angle of elevation. We know that we want to make a right triangle, and most students will put the angle of depression inside the right triangle. But the problem here is that if you look at the sides of angle X, this is vertical, this is not, this is your line of sight, neither one of these is horizontal. Therefore, neither one of, or this angle cannot be an angle of depression. And it's very, very important to remember that an angle of depression must have a side that's horizontal. And this is the common mistake. So when you're drawing an angle of depression, you have to draw in this imaginary horizontal line, and your angle of depression is actually this angle out here, not in here. Now, this is the problem that's made most often, is that when we draw a right triangle to represent the situation we're looking at, the angle of elevation is always inside the triangle that we draw and that we then work with in order to determine the missing leg. The angle of depression itself is not in the triangle. It's outside of the triangle. But we use what we know about the angle of elevation and the angle of depression being alternate interior, and so this angle of depression can be used to determine one of the angles inside of the triangle, even though the angle itself is not in the right triangle. So it's very important to remember when you're working with angles of depression. The angle of depression is most often, because of the way we draw the diagram, not in the right triangle that we're going to use to solve for the missing leg. So we have to use what we know about angles of depression, the fact that the angle of depression and the angle of elevation are the same, and use that and make it the conclusion, the deduction, that then this would be the angle that we want to use in our triangle. So very important to remember, you must have a horizontal side when you're working with angle of depression or angle of elevation. And the angle of depression itself is not in the triangle that you're going to be using. But you can use the information and what you know about the angle of depression to determine the angle that is in the triangle and then use that to solve the problem. A couple of examples then, just to get the idea of angles of elevation and angles of depression. If we wanted to describe each angle as it relates to the situation, angle 1 would be an angle of depression from someone standing on the peak looking down to the hiker. Again, angle 1 has this horizontal line here and then the line of sight looking to the hiker. Angle 4 would be an angle of elevation of someone looking up from the cabin to the hiker. And angle 4 again has this horizontal component to it, and then the line of sight would be the other side of the angle. So what would angle 2 be then? Well, if we're looking at angle 2 would be an angle of elevation from the hiker looking up to the top of the mountain or the peak. The horizontal line, imaginary, drawn here, the line of sight, the other side of the angle, so we're looking above the horizontal, therefore an angle of elevation. And then angle 3 would be an angle of depression because the person is looking below horizontal, looking down to the cabin, so this would be an angle of depression from the hiker looking down to the cabin.